Hello, everyone. Today we're going to be talking about technical presentations. I've brought special guests, my peers at Syracuse University, to help me show you what a good technical presentation might look like and what a bad technical presentation might look like. We were debriefing a theoretical situation in which we were asked to create an orbit for a satellite around the moon to scan the Sea of Tranquility and select a rocket to launch said satellite into a translunar injection orbit and select the components for the satellite to scan the Sea of Tranquility. So let's take a look. Hi guys, we're here today to show you an example of what a good presentation will look like.
This is by no means the best presentation, but creativity is always welcome. So, let's get started.
Hello and good morning, everybody. My name is Hans Christian Esser, and this is the Sky Dragon team from Syracuse University. We are a group of aerospace engineers, and this is our mission debriefing on how we took pictures of the lunar surface.
Hello, my name is Sarah Gladson, and I will be debriefing you on the orbit that we selected. So the apogee is the furthest place that our satellite will be from the lunar surface, and the perigee is the closest altitude. We selected an apogee of 122 kilometers and a perigee of 100 kilometers. We selected this so that we'd have a slightly elliptical orbit that was almost circular. This allowed us to collect data from a nearly constant altitude while also allowing us to slow the satellite at apogee when it was above the Sea of Tranquility, which was the area of interest in this mission. The inclination is the angle at which the satellite's orbit path makes with the plane of celestial equator. So we selected a relatively low inclination because the Sea of Tranquility is near the equator of the moon. This allowed us to collect a lot of data from the Sea of Tranquility while not wasting time further away from it. In addition, the argument of the perigee is the angle at which the perigee is from the position of the orbit. And so we selected an argument of the perigee of 175 degrees. This allows us to slow the satellite on the other side of the moon from the Sea of Tranquility. Given that perigee is the place where the satellite is traveling the fastest, and so I spoke incorrectly. The apogee is where we slow the satellite, and that is where we wanted the satellite to gather data, so the argument of the perigee was placed on the other side of the moon from the Sea of Tranquility. The right ascension of the ascending node is the point at which the satellite passes from southern hemisphere to northern hemisphere. We placed that at 165 degrees. This is the swivel, and in this case, it wasn't the most important selection we made, given that our inclination is relatively low, so it didn't affect our data gathering significantly. Finally, the true anomaly is the angle at which the satellite is placed in the orbit at the beginning of the time period. We selected a 3-degree true anomaly because, given our calculations in System Toolkit, this showed us that we would collect the most axis coverage data from the Sea of Tranquility.
My name is Paul Mokotov, and I'll be taking you through the equipment that we selected for our satellite, as well as the launch vehicle and the site itself. Just as a reminder, our mission is to send a satellite into orbit around the moon to gather imaging data of the lunar surface, specifically the Sea of Tranquility, to find an ideal place to land. For our surface scanner, we selected the SureScan 150. This will scan at a half-cone angle of 12 degrees, which is pretty good for its cost and weight. Our research transmitter is the Clear Signal 40. It is a little less expensive than we thought, but a little more heavy. However, it will do a good job in sending the imaging data and other relevant information back to Houston. Our attitude control system is the Horizon 100. For a relatively low cost and weight, we're able to get the control that we need to keep the SureScan 150 pointed towards the lunar surface at all times, therefore ensuring the highest quality images that can be sent back to Earth. For the 2-week mission, we will be using a Tesla 3300 battery, which, for again, a relatively low cost and weight, will satisfy our needs for the mission. Lastly, we will be carrying an additional 44 kilograms of hydrazine with us. That way, we can correct the trajectory as we orbit the moon if needed to again obtain the highest quality images of the lunar surface. For our launch vehicle, we will be using the Bernoulli 6, which is manufactured by JFD3 Enterprises. For our mission, the Bernoulli 6 provides the appropriate thrust required to get our satellite into a translunar injection orbit. We'll be launching out of Cape Canaveral at an angle of 32 degrees. We selected Cape Canaveral as our launch site because it can accommodate launch angles from 28 to 57 degrees, therefore satisfying our requirements. And also, we will not be sending any CubeSats up with our current satellite because of the additional weight that the Clear Signal 40 brings onto the payload. However, we were able to spend a little less money with the SureScan 150 and Horizon 100. Therefore, the additional revenue from carrying CubeSats is compensated for.
My name is Jodich, and this is the perspective schedule for our team. For the first hour, we did a close reading of the mission booklet. Then, we just divided into our STK and XL groups. I was the XL group lead, while Soretta was the STK group lead. For the fourth hour, we discussed our next plan of action at lunch and reviewed all the facts that we came to at this point. For the fifth and sixth hour, we collaborated and switched our groups, meaning the people that weren't the leads of the group switched into the STK or XL groups respectively. For the final 2 hours, we reread our scenario and checked our work to find any prospective errors.
Thank you so much. That concludes our presentation. And if you have any questions, we're happy to answer them right now.
Now let's look at an example of a bad presentation.
Here are some examples of the common mistakes people make.
See if we can find them all.
Let's get started.
Hi, my name is Hans Christian Esser, and this is our team for the STLX 0312. Yeah, okay, we're the Sky Dragons. We're a team out of Syracuse University, and this is our mission debrief.
Switch the slide.
Oh.
Yeah, so my name is Soretta Gladson, and I will be telling you the orbit that we selected. We selected an apogee of 122 kilometers and a perigee of 100 kilometers. Our inclination is 1.25 degrees. Our argument of perigee was 178 degrees. Our RAN was 165 degrees. And our true anomaly was 3 degrees. So, yeah.
Hi, I'm Paul Mukhtoff, and we're going to be talking about the satellite equipment and launch vehicle site. So our mission is to send this satellite to orbit the moon and take some pictures of the Sea of Tranquility. So our lunar surface scanner is the SureScan 150, the research transmitter is the Clear Signal 40, the attitude control system goes Horizon 100, the battery is the Tesla 3300. We're going to carry 43.83 kilograms of hydrazine with us. Our launch vehicle will be the Bernoulli 6 made by JFD3 Enterprises. We're launching out of Cape Canaveral AIS, and 0 CubeSats are coming with our satellite.
Alright, my name is Jodich, and this is the schedule for our team. So basically, we start off by doing a close reading of the mission booklet, where we'll figure out what we're gonna do for the project. Then for the second hour, we're gonna split into our STK and XL groups. And then for the next hour, we're gonna discuss our plan of action at lunch. We're gonna figure out what we've learned so far and where we're gonna go from there on out. For the fifth and sixth hour, we're gonna collaborate and we're gonna switch our groups. If you were on one project, you're on the other one now, and vice versa. For the last few hours, we're gonna reread our scenario and catch any errors that might have came up while we were calculating and running our tests.
Okay, cool. So thank you so much. That was our presentation. So yeah, good.
Not bad.